There is no simple rule for when you're adding or subtracting two surds. You can't, you can't do this, for example. So the question is, how are we going to simplify to enable us to get root 2? And the answer is that we need to try and square it. So if we can square the left-hand side and show that it is equal to the square of the right-hand side, then we're pretty much there. You just got to basically see that actually this thing here is positive. I'm not going to write any more about it, but technically, if you squared -2, you'd get 4, and if you squared 2, you'd get 4. That doesn't mean that -2 is the same as 2, because one's negative and one's positive. But in this case, like because this is positive and this is positive, we're okay. I just wanted to sort of mention that. So here goes. We can basically go and write this. And then times it by itself. I'm going to times these two. I'm going to get 2 plus root 3. I'm actually going to deal with this one because this would be, equally as easy to deal with. So when I times this by this, I'll get positive 2 minus root 3. And then I've just got to deal with these crossover terms. Oh, sorry, this should be a minus. So I've done this one times this one. Now I'm doing the first one times the last one. And then I've got to deal with the second one times the third one. And that will be the same as the first times the last. So I'm going to get 2 lots of this. There can I cancel. So we're going to get 4 minus 2. Now I can bring this into the same square root. Okay, because there is that rule. Square root of a times the square root of b is equal to the square root of ab. So that's going to give me 4. And then now I've got sort of a difference of 2 squares thing going on. 4 minus 3. And that's all we need, really. We've shown that when we square it, we get 2. And we're done with part A. Brilliant. So let's take a look at part B. Hence prove that the log of that first, the left-hand side of part A, log to base 1/8 is minus 1/6. Well, first things first, we can write that it is log 1/8 simply of root 2. There's a couple ways we can deal with that now. I'm going to go the route of trying to get this sort of in terms of 1/8. So first things first, I can write it as log 1/8, 2 to the half. and that's going to mean it's a half log 1 over 8. Now actually, it's going to be, if I can get an 8 in there, that would be really useful. So I can change the 2 to the cube root of 8. And this is going to be 8 to the third, so I can write down that it is log 1/6 log to the 1/8 of 8. And because this is the reciprocal, that's just going to give me a negative. Like I could write it, maybe if I want to show enough steps, I could write it as 1 over 8 to the minus 1. So that will be 1/6, or minus 1/6 log 1 over 8 to the 1 over 8, which is going to give me 1 minus 1/6 as required. The other thing we could have done is we could have, say, let x equal log 1 over 8 root 2, and that would mean that 1 over 8 to the x is equal to root 2, and we could have solved that. So you might prefer it that way instead. Finally, let's deal with part C, which is by far going to be the most challenging part. 3 marks, 3 marks, 13 marks for this bit here. So find all possible pairs of integers a and n such that this is true. Okay, now we've been given some hints there. We've seen that you can simplify these surds. And so it makes sense, first of all, to try and deal with that. And we can do that by squaring it. So this is going to work out in a similar sort of way. Okay, first two terms and the second and the fourth term. That's similar to before. And then the first and the last term. And then the second and the third term is going to be the same. So we get this. I didn't think I could fit it in, but I can fit it on one line. Multiply these out. We're going to get, I can just deal with this, it's going to be a squared minus 15. Okay, so it's not quite as nice as before, but it's not too bad. So what does that mean? Well, we can write down that log 1 over n of 2a okay, if I raise all of this to a half, because remember we squared it, so we have to square root it to get it back to what it actually is. That's equal to minus a half. I can bring the half down, and then I can actually divide by a half. So we're going to get minus 1 there. Now here's something to be aware of, the fact that actually if you have log 1 over x of a, let's say that's equal to y, then 1 over x to the y would equal a, or x to the minus y would equal a, or x to the y would equal 1 over a. I've basically taken the reciprocal, and from this we're going to get that log x 1 over a is also equal to y. Or actually, this would have been, sorry, this one would have just been just as useful. Log to base x of a is actually equal to minus y. That's the one I'm now going to use. I've just sort of written this out. So log to base n of 2a minus 2 a squared minus 15 is actually just equal to 1. I mean, I did that. I mean, basically, we're trying to get to this next line, get rid of the logs. So that is therefore going to equal n to the 1, which is just n. To be fair, we could have written it as 1 over n to the minus 1, which would have got us n as well. It's nice to see this result, though, so I don't regret that. Right, now let's just look back at the question, because it said, find all possible pairs of integers a and n, such that this is true. Now, if a is an integer here, then it's absolutely fine, but we need this to be an integer. We require a squared minus 15 rooted to be an integer. We can actually just focus on this now. So a squared minus 15 must equal b squared, where b is an integer. Basically, a squared minus 15 is a square number. Remember, we're mainly interested in a and n. I've introduced this new b. Now, there's two ways you can deal with this now. I dealt with it one way, and I actually missed the solution. I'll come back and talk about it at the end, because I think it's a bit, well, it's the one that was intuitive to me. The one that was less, well, I look at it now and I think, yeah, this is a much better method, but I didn't think of it at the time, is to basically treat it as a difference of two squares, right? A squared minus b squared equals 15. Now, when you normally have just any numbers, you don't want to deal with a quadratic like this, because you always try and get it equal to 0. But because we know that a and b are integers, this method comes into its own. It's technically a Diophantine equation, because you are trying to find integers and all integer solutions to this. And what we can do is we can write it as a plus b, a minus b equals 15. And because a and b are integers, then a plus b and a minus b must be integers. So we just need to find our factors of 15. It's going to be 1 and 15, or 3 and 5, and those are the only options. So if we take the first one, we can write that a plus b is equal to 15 and a minus b is equal to 1. Add these two together. This gives 2a equals 16. That gives a is equal to 8. Now, note, if you changed it round to a plus b equals 1 and a minus b equals 15, you would still get a equals 8. You would just change your value for b. You'd either get b is 7 or minus 7, so that is not particularly important. A is 8 as a solution, and what goes with it is that n is then this. So it's going to be 16 minus 2 times the square root of 64 minus 15. Now that's 49. Square root of 49 is 7, so n is 2. Or we've got to look at the other one. A plus b is going to equal 5. A minus b is 3. So 2a is 8. A is equal to 4. When a is equal to 4, n is going to be 8 minus 2 lots of 16 minus 15. That's just 1, so it's going to be 8 minus 2, and n is going to equal 6. These are the only solutions. Now, I just want to show you what I personally did when I solved this question. I basically wrote down my square numbers. And I also sort of wrote down the differences between them, because basically I'm trying to find the difference of 15. Okay, and that gave me one solution, because I'm interested in taking a square number, minusing another square number, and getting 15. So a was equal to 8. B would have been 7. Now what this missed, however, when I did this is these two, because they don't have to be consecutive. So like my method's nice in that respect. It's quite a lot easier than dealing with a Diophantine equation and finding the difference of two squares, but you've got to make sure you're really careful. And have I proven there aren't any others? Like, okay, consecutive, differ by 4. I guess you could say, well, none differ by 3 or by 2, so that would be sufficient. So I would be happy with that. You just have to like justify why there are no other solutions. In any case, these are the solutions. That was I like that question a lot. A lot going on. Interesting little, entry into the idea of solving Diophantine equations, a massive topic of maths, not often, or not covered in schools really. Even part A is pretty neat, but it really goes next level at the end.